Okay, so we have system of three equations in the unknowns x, y, and z. To solve, the only task I gave you at this point is eliminate one variable between two equations. Then eliminate that same variable between two different equations. So what we're going to do is we're going to do, let's say, multiply equation 2 by -1 and add that to the first equation, okay? Because that'll eliminate z. So if I multiply each of these by -1, and actually I'm going to stop a minute. No, that's what I'm going to do. Okay. So off to the side, I can write I don't want to write it here because I want my solution to include just the essential parts here. So I want something that I can follow the flow of. I don't want to do all my calculations in here. Okay, so all my calculations I'm actually going to do over here. Okay, and then minus 3x minus 5y plus z equals minus 2. There's a negative on both sides of equation 2. So here I'm multiplying equation 2 by -1. I could put -1 here and -1 here. I don't really have room. Okay, -1 times both sides. I get -3x minus plus 5y minus z equals -2. Okay, now you can't even read that from back there. It's the same thing you did, except I think maybe you multiplied the first one by -1. I don't remember, but it's fine. It's fine. Okay, so what I've done is I've just done that little calculation, -1 times equation 2. And now I'm going to take that equation, -3x plus 5y minus z equals -2. And look back at my original equation, make sure every sign is changed, and it has. And then I just add these, and I get x plus 8y equals 6. Okay. Now, if you did the second equation and -1 times the first, you'd have ended up with -x minus 8y equals -6, right? Is that what you got? Okay. So I'm just confirming that I did it right, because I'm sure you did. Okay. So if I do that operation, I get x plus 8y. I'm going to keep my equal signs kind of carefully lined up here. So here I have an equation of just two variables. Now I'm going to do the same thing with two other equations. It could be either the first and third or the second and third. Okay, doesn't matter which one I choose. So I'll choose the second and the third. Okay, and I'm going to do -1 times the second equation added to the third. Now I've already got -1 times the second equation sitting right here. So I kind of jot it down over to the left here. I do third equation, -5x plus 7y plus z equals -7. -1 times the second equation. You can't read that, but there it is. And it's what we did here. We got -3x plus 5y minus z equals -2. We add those together and we get -8x plus 12y equals 5. Okay. Did you use those two equations? Is that what you got? -8x plus 12y equals 5. Okay, hang on. Let's take a look. Okay, there's a -7 and a -2. Somehow I missed the negative on the 7. And it is -9. Okay, so now I have -8x plus 12y equals -9. Okay, so I've reduced a system of 3 equations to a system of 2 equations. And now we know how to solve a system of 2 equations, presumably. And since everybody that I see working here has successfully eliminated a variable from each of a distinct pair of equations, of the original equations, I think we can count on the fact that everybody can solve this equation. So, and today I'm not going to talk about solving a system of 2 equations. As we talked about last time, did it in detail, and people appear to have done it quite well on homework. Homework results were pretty good. Now, you know, on the homework, it says solve the system by elimination. I have no way to check whether you solved it by elimination. Okay, some people might have solved it a different way. So elimination is what we're using, and that's what we need. So I hope everybody used elimination. But people did well on the homework, so on 2 equations. So all we really need to do is see how to reduce 3 equations to 2, and we're done. Okay, and then I know that you can solve a system of 3 equations. Well, just to complete the solution, in order to eliminate a variable, I could multiply the first equation by 8 and add it to the second equation. I'd have 8x and a -8x, and I'd get an equation for just y, right? Or I could multiply the first equation by -3 and the second equation by 2, which would give me 24y, -24y and 24y, okay? Either way. Now, I find it really convenient because the numbers aren't that big to go ahead and multiply by 8 because I've already got my negative sign there. There's just one opportunity for an error that I am going to avoid. And especially since you saw what I did with -7 and -2. Okay, so I'm going to do equation 1 times 8. And I'm going to go ahead and just write out equation 2. And we'll do it all in one step. So, okay, so I've got 8x plus 64y equals 48. And I've got -8x, x, already looking forward to y, plus 12y equals -9. If I add these up, then we get 76y equals 39. So y equals 39 over 76. Now, why couldn't it have been 39 over 78? That would have been 1/2. But it's 39 over 76. And 39 is 3 times 13. 3 and 13 are both prime. 76 is 2 times 2 times 19. So they don't have any common factors. So that kind of stuck with this fraction. And now what we have to do is we can back substitute this into one of these 2 equations and get a solution for x, which will be another ugly fraction. And then substitute both of those into any one of the first 3 equations and get an even uglier fraction. Okay? So I'm assuming we know how to do that because we've been over that in some detail with systems of 2 equations. It's really no different. You substitute this into here, and then you'll have both X and Y after you solve it. And then having X and Y, you can substitute into here and solve for Z. Then you check by plugging all three numbers into one of the other equations. Okay. So that's it. So I solve a system of three equations and three unknowns. Now I can do the same thing without having to write out my X's and Y's and everything. And if anybody who wasn't here last time, at least one person was out sick. It's good to see you back healthy again. Might not have seen how we represent this as an augmented matrix. It's coming up, but I want to anticipate it for next week because it gives some people trouble. Okay, so the augmented matrix is going to be just this. I just take my numbers, 4, 3, 1, the dotted line here, and an 8. This represents the first equation because it's understood that this is the coefficient of X. This really means 4X. And this means plus 3Y. And this means plus 1Z equals 8. Well, that's easy to understand. So we're going to do 3, -5, 1, 2. And -5, 7, 1, -7. Okay, so what we do next, it's a little different. And it's going to get a little messy because I didn't intentionally make up easy numbers here. Okay. We're going to want to get a 1 up here. Okay. Now we're going to get a 1 up here. Now we could do that by subtracting the second equation from the first, right? Okay. And actually, that's not a bad idea. Another way is just multiply the whole equation by 1/4. Well, that would give us fractions. So what I'm going to do is I'm going to do equation or line 1 minus line 3 minus line 2 as looking at the 3. Okay. Line 1 minus line 2. Now I can calculate that out here. You know, I've got 4, 3, 1, 8. And I'll do -3 plus 5 minus 1 minus 2 and add those together and I get 1, 8, 0, 6. Okay. So it's easy to do that. So my first row is going to become 1, 8, 0, 6. Now I'm going to just write down equation 2 and equation 3 as they already were. Well, now look at what I can do. Okay, the next thing I want is I want zeros here and here. Now that would correspond to eliminating X from these two equations. Okay. So what I do is first I write down equation 1. Now, equation 1 is this equation, or I wrote row 1. I should be saying rows, but they represent equations. Okay. And again, this row represents the same equation you get if you subtract this line from this, which would be minus X plus 8Y equals 6, which is X plus 8Y equals 6, right? X plus 8Y equals 6. All right. Okay, so anyhow. I then add -3 times this equation to this equation. Okay. I can do that. Gives me a new equation. And that's essentially what I'm going to do here. I'm going to do I'll say just equation 2 minus equation 1. Okay. So I can do that. That's easy. I can do 3 minus 1. First of all, I write down equation 1 or line 1. Then I do equation 2 minus equation 1 or line 2 minus line 1. And it's not the equation 2 minus equation 1 or line 2 minus line 1. It's equation 2 minus 3 times equation 1. Okay. And then down here, I'm going to do equation 3 minus plus 5 times equation 1. Okay. Now I'm just going to do it. Okay. I'm going to do this equation 2 minus 3 times equation 1. So 3 minus 3 times 1 gives me what? Nope. Yeah. Okay. Okay. Again, arithmetic. 3 minus 3 times 1. Minus 3 times 1 is -3. And I add that to 3. And I get your second choice. Yes, I know you're embarrassed and you're laughing. And that's fine. Okay, you know better. Okay. So we got 0 here. Okay. Now we got to do the same thing here. We do this number minus 3 times this number. Figure that out real quick. Close. That gives you minus 24, right? 3 times, -3 times 8 is minus 24. If we add that to minus 5, we get minus 29. Okay. And then I'll bet this one's easy. What if you do this minus 3 times this? Nope. What's 3 times this? You just showed me. What's this minus 3 times this? It's 1 minus 0. No, 1's not multiplied by 0, you're subtracting 0. Yeah. No, it's not -1, it's 1. Okay. That's okay. Put your head in your hands. It's fine. You know better. Okay. Now, so you really probably better write these out to the side because you take little mental errors, but I'm not giving you a lot of time. You're under pressure. Okay. So then 2 minus 3 times 6. Well, 3 times 6 is 18, so that's minus 18. 2 and minus 18 is -16. Okay. You understand what we just did? That is what happens to take row 2 minus 3 times row 1. Okay, now see if you can work out row 3 plus 5 times row 1. See what you get. Okay, now you've done this in your head, and maybe it's right and maybe it's wrong. Okay, but what you really want to do is write it out like this. Okay, So the one we just did, I wrote equation 2, because we're doing equation 2 minus 3 times 1, right? No. Okay, this is what we're doing now. This is what we did before. Okay, just review what we did before and see how it looks here. Okay, we did equation 2 minus 3 times equation 1, right? To do that, I could have written out equation 2 because we just did it in our heads and made a few mistakes, but you know, we had the right idea. Okay, here's equation 2, or line 2, 3 minus 5, 1, 2, right there it is. Okay, and equation 1 or line 1 is here. It's 1806, but we're going to multiply it by -3. And -3 times 1 is -3. -3 times 8 is -24. -3 times 0 is 0. -3 times 6 is -18. So here they are lined up. Now all I've got to do is add 3 and -3 gives me 0. -5, -24 gives me -29. 1 and 0 gives me 1. 2 and -18 gives me -16. Okay, so I would write the whole thing out here rather than doing it in my head. I would do this. Okay, so I've already written line 3 because we're down here. We're looking back at the previous line 3, right? So I'd write line 3 out here, and then I'd write 5 times line 1 here. Okay. Then I'd just add the numbers. Now, people find this challenging for a number of reasons. One is they don't do what I say. Okay, no offense to anybody here who didn't do what I say, because there's always a tendency in my work as a same. When I'm doing something I'm unfamiliar with, I don't know how to organize it. So it's all over the place. Okay, then I start understanding something. Okay, I start understanding the flow of the problem, and then I can rewrite it where I can see the flow. Okay, but on the first attempt, I've got stuff all over the place trying to find what I need, like trying to herd cats. Okay, it's scattered here and there. Okay, but I'm more experienced at learning this stuff. And I'm talking about stuff that's challenging for me. It's the way I work. I don't work as systematically as a lot of other people. Okay, it gives me certain advantages and certain disadvantages. If I'm trying to compete with other people. So it's kind of a wash. Everybody has their own way of approaching things. Okay, so does everybody here. Okay, well, my whole point is, I'm saying we want to write out a matrix. And then we want to write out another matrix showing what we did at every step, right? And then we want to write out another matrix directly below that. We want these matrices to be lined up. We want the dotted lines to be lined up. We want the brackets to be lined up. Although sometimes we don't anticipate something and we get a big long number and it throws our alignment out. So we try to avoid that though, giving ourselves plenty of space, for example. Okay, so I've written this down. Now, what I saw among a lot of what I usually see is people just don't write this down. They just start doing all this stuff and lose the thread of what they've done and totally lose the content of what they've done because most people are not as good at herding cats as I am. Nobody's very good at it. Okay. So we've got this, okay? And at this stage, we want to have this written down before we start trying to do this. Okay, well, now we try to do this. Okay, and now what I've done here, well, first place, I've written down this operation, okay? I think I've already said this, but I'll say it again. I'm not sure I had the video on when I did. We're doing 2 minus 3 times equation 1 here. So what do? I write down 2, equation 2. There's equation 2, or row 2, okay? Then I write -3 times row 1. Well, here's row 1. I can do -3 times 1. gives me -3. I can do -3 times 8, gives me this. I do -3 times 0, it's 0. I do -3 times 6, and it's -18. Then all I've got to do is add. 3 and -3 gives me 0. -5, -24 gives me -29. 1 and 0 gives me 1, not 0. We're not multiplying. 2, -18 gives me -16. Okay. Now we want to do exactly the same thing here. So we write down row 3, which is this. And you see I've repeated that. And then we do 5 times row 1. Now what I've seen is so I just wrote down row 1 and then multiplied it by 5 and put that down here. Okay. And again, just try to herd cats. Okay. It's just not, first place, it's not what we said. We said this is 5 times row 1, but then you just write down row 1. Well, I said, okay, so let's say you did write down row 1. So row 1 is 1, 8, 0, 6. Then you say, wait, this is supposed to be 5 times row 1. You don't write it down here. You write it where it says 5 times row 1, and you write 5 here. And you do 5 times 8, which gives you 40, and 5 times 0, which gives you 0. Didn't have to erase that one. And 5 times 6, which gives you 30. Then you add these things. You're going to get 0. You're going to get 47. You're going to get 1. You're going to get -23. Okay. Now you write it down here. And this is locked in. Doesn't have to change. You don't move it around. Lined up. Okay. And here we've got 0, 47, 1, -23. Now it turns out it would be really easy to get a 0 here or here, just by subtract this row from this one or this row from this one. Okay, but we don't want a 0 there unless we got a 0 here or here. Okay. So our next step is going to be to get a 0 here. And then we want to get a 0 here. Okay. And we're not going to do that today. Okay. We've got a 0 here, then we get a 0 here, then we want a 0 here and a 0 here. Actually, we want a 0 here and a 1 here. So, okay. And we'll go on with this. Right now, main idea. And this is challenging for people, partly because there's a little bit of a distraction with the fact that people are too calculator dependent and don't see the arithmetic. Okay. And it just goes back to the pervasive misuse calculators and the de-emphasis on understanding numbers and thinking. It's okay to do these with calculators because a lot of times the numbers are big and you have to anyway. But there's a little bit of a problem, and this is more a problem than it should be. So we're trying to do this in a very systematic manner. Okay. So right now, to start solving one of these equations with one of these systems of 3 equations and 3 unknowns using the augmented matrix is get a 1 here. Okay. And often you can do that by adding a multiple of another row to the first row. Another alternative is just multiply the first row by 1/4. It's going to give you fractions, but as you see, we're never going to get away from fractions. At this point on, we got ugly fractions. Still, it's okay to avoid ugly fractions. Get the 1 here by hook, by crook, or whatever it takes. You get a 1 here. And then that makes it easy to eliminate, well, to get zeros here and here. It just says I take minus 3 times this and add to this, I'm going to get 0. So I take minus 3 times the first row and add to the second row, gives me a 0, and it gives me some other numbers. These other numbers represent an equation that's still valid. The solutions to this equation, well, the solutions to the whole system will solve this equation, okay? It's always the case. We get equivalent equations. We get an equivalent system of equations at each step. Okay, so anyhow, use the fact that we got 1 here to figure out what to do in the first row to get a 0 in the second row. In the first column. And then we do the same thing to the third row. Now we've got a couple of zeros. Okay. Next thing we want is actually going to be a 1 here. If we've got a 1 here, that's going to be easy to get a 0 here. But we're going to use that later. Okay. So right now the assignment is be able to solve a system of 3 equations and 3 unknowns, just using multiples of the equations, just using this process. You won't have to worry about this until the following assignment. We're getting toward the end of the semester, so we want to get a good start on the use of the matrices. Okay. In general, if you transform a function using vertical stretch, horizontal and vertical shift, and I'm not including right now horizontal compression, but you should be able to do that too. There are 3 things that you might not know. Okay, so if you have,
I know it's like winter.
if you have data, you might be able to find the coordinates of 3 points. In the XY plane. It fits the desired function. Then y equals AF of x minus k gives you 3 equations. One for each XY point. Okay. That is, if you plug the values of x and y into the function, if you know what function it is you're trying to use, then you only have 3 unknowns, A, H, and K. If you have 3 equations and 3 unknowns, you can solve them. hopefully. Now, I've tried to do this with three unknowns with an exponential function. Okay. And the problem with an exponential function is you never can figure out what k is because you can't figure out what the asymptote is. So I kind of proved to myself that you can't do it. Then I went to ChatGPT. See if ChatGPT, because ChatGPT has access to some very deep mathematics. It could be something I'm just not seeing. Okay. I mean, I see that you can do it by successive approximations. You can approximate what k ought to be. And every different value of k gives a different value of a and h, and you don't know what I'm talking about, but there it is. But what you do know is that if you have three equations and three unknowns, three linear equations and three unknowns, you can solve them for the three unknowns, okay? Three equations and three unknowns do have a solution most of the time. And in the case I was talking about, well, the very first thing ChatGPT told me was, no, you can't do it because you've got 3 points and you got three equations, and it's three equations and three unknowns, and you can't solve three equations and three unknowns. That was ChatGPT's first response. So ChatGPT said something ridiculous. You can solve three equations and three unknowns. If they're linear equations, you can always solve them, okay? If they're nonlinear, well, you might have to use approximations. So I started telling White ChatGPT, you know, yeah, that was ridiculous. I didn't say it in those words. And then ChatGPT, oh, okay, you're right, I apologize. Here, let's try this. Okay. And it gave me something a little better, but it didn't fit all the cases. And I finally pinned it down to where it actually was able to give me something like a proof. Something like a proof. That you can't do it. And the proof is pretty much what I've already figured out. But I think that there's no way for an exponential function. Well, that's a digression. And a little bit about ChatGPT, which is always entertaining. I mean, so, you know, sometimes the stuff you get out of it is really good if you keep pushing it, if you know what to push, okay? And sometimes the first questions are really good. I ask it to give me an explanation, an overall explanation of Lagrangian mechanics. It's going to give me a good one, okay? But then when I try to push it into details, I better know what I'm doing better than I do. Or I just have to remain real skeptical about what it's telling me and work it out for myself, okay? Because I can't trust it on the details. Okay, because it'll tell me things like you can't solve three equations and three unknowns. Everybody knows that. All right, well, that's kind of the overview, but here's kind of what it comes down to. They got the points 2, 7, 7, 3. Better rewrite that. Left click. There you go. Okay, so now I'm just going to ask you, what two equations do you get if you know that this is the form and you've got these points? Okay, now what I really want to do is just write the equations, and it's easy to do that. Your equations would be, if y is 7 and x is 2, it's 7 equals a b to the second power. And if y is 3 and x is 7, you get 3 equals a b to the 7th. Okay? Now, I'm just going to jot this down quickly because I think you might see it. You did solve equations by substitution. Seven equals ab to the second, so a equals 7 divided by b to the second, right? And the second equation becomes 3 equals 7 over b to the second times b to the seventh, because I've replaced a by 7 over b to the second, right? So just take that and plug it in here, and we get 3 equals 7 times b to the seventh over b to the second. So 3 is 7 times b to the fifth. So that b to the fifth equals 3 over 7, and b equals 3 over 7 to the 1/5 power, which you approximate on your calculator. Now you're going to need to look at the videos where I do all the intermediate steps and explain this, but that's just straightforward algebra. Okay. So it's explained in more detail. Okay, well, let's say at the same points to y equals a equals x to the p. And to y equals ax plus b. And we could even do another form of quadratic. Then y equals a times quantity x minus 7 squared plus k. In each case, you only have 2 unknowns. In each case, you get a system of equations. Okay. Now I think you can do this. I'm just going to write down the systems. You get y equals ax to the p. If y is 7 and x is 2, you get y equals a x times 2 to the p. And it's 7. Okay. If y equals 3 and x equals 7, you get 3 equals a times 7 to the p. Again, you can solve for a in one equation and plug it into the other. The equation you get in this case will require logarithms because your variable P is in the exponent, and you got to solve for it. Okay. So just a little overview then. Okay. If you've got y equals ax plus b, then you get 7 equals 2a plus b, and you get 3 equals 7a plus b. Well, that's just two simultaneous linear equations and two unknowns. And you can eliminate b very easily. Just subtract the second equation from the first. And then you can solve for a and plug that in and get b. Okay? So that's real easy. That's just what you've done for homework. You did some things with substitution as well. So might want to review that. And finally, this quadratic form, you would have 7 equals a times 2 minus 7 squared plus k. And 3 equals a times 7 minus 7 squared plus k. And of course, you can square 2 minus 7. This is going to give you 0 coincidentally, but usually it won't. But you see that that's just going to give you, these are just going to be numbers. It's just going to be some number times a plus k. This is going to be some number times a plus k. So it's going to give you two linear equations again. Now one more. Now, I'm not going to be able to come back to my original plan there, but let's see what this is, okay? Let's say this is -2, 6, and this is 4, 1, and this is 9, 3. Okay. So we want to fit y equals ax squared takes bx plus c. Well, first one on the left, y is 6. X is -2. So we plug in -2 for x. We get this. And then for the second one, we get 4 equals a times 4 squared plus b times 4 plus c. In the third one, we get 3 equals a times 9 squared plus b times 9 plus c. Do the arithmetic. We're going to get 4a plus 2b plus c equals 6 from this equation. We're going to get 16a plus 4b plus c equals 1 from this equation. And we're going to get 81a plus 9b plus c equals 3. And there's a system of 3 equations and 3 unknowns. And if you look at them, you see it's going to be really easy to reduce this down to 2 equations and 2 unknowns because you can eliminate c from the first 2, just like we eliminated z in that first equation. You can eliminate c from the second and third or the first and third, okay? And you get 2 equations and 2 unknowns that you can then easily solve, okay? And what do you have then? If you find a, b, and c and plug those numbers in, you have a quadratic equation or quadratic function with an axis symmetry at -b over 2a zeros at negative b plus or minus the square root of b squared minus 4ac all over 2a, okay? So this tells us that there is a quadratic function that fits these points. Okay, how would you draw the quadratic? You know, I don't know. Probably come down about it. So maybe up there. Okay. There's one specific quadratic function that goes through these 3 points, and that quadratic function has A, B, and C values that you can get by solving these 3 equations. And that's really cool.